So a couple of things I just wanted to point out while I can, and that is that when I'm organized, which is not all the time, what I'll do is I'll use the screen and my iPad here to write the board notes as we go along, with the idea that then those board notes will be available to you as a PDF on Google Classroom, which everyone's been invited to. And if you haven't yet clicked on the join button, please do so. And the other thing is, you'll see I'll have got my earphone in because I'm recording it as well. So at the end of it, I can do a video. I can release the video of the notes as well for you to, sit back and relax and enjoy on a Saturday afternoon as you do. Put on some maths. Well, just when it comes to like exam time and stuff, at least you can rewind through the notes and that kind of stuff. That's the idea anyway. So just really quickly go through these starter problems to make sure you're okay. I guess the trick with these kinds of problems is the intuitive thing is to know how to unpack the variable you're looking for. Those formal notes I gave you last lesson is one thing to look at, and that definitely will give you a process to follow. But I don't like it. It's a place to start, but I don't really like it. Growing that sort of intuitive sense. And one of the things you can do is, if I just zoom up on that for a second, is if you sort of have a look at the variable you're looking for, which is P, and say, well, how is that built? How is that expression built up? So you can see you've got a P there, and the P has been squared, and then Q is added to that, and then the whole thing has been square rooted. By taking a moment to work out how it's built up, you basically just need to unbuild it in order to get your way through to the P. So if the last thing I've done is square rooted that expression on the right, then it's the first thing I need to do to undo it. So just really quickly then, I square both sides and I get n squared on the left, and I get p squared plus q on the right. I've got a p squared plus q, so I'm going to take away q from this side to remove it. That gets me closer to the p I'm looking for. And then I have to do the same thing on that side in order to keep it balanced. And then I'm not looking for p, I'm looking for p squared, I'm looking for p. So I have to square root both sides. So I'm left with p on one of the sides. I've just switched sides at the same time, and I've got the square root of n squared minus q on that side. So give yourself a big tick of satisfaction if you got the square root of n squared minus q. And if you didn't, just make sure you've highlighted it to come back to. With the other side, we've got s squared equals a plus s cubed over 1 plus s. And it looks complicated, but it's not that hard to solve in the end, really. It's got s's all over the place. That's trouble. And the other thing is just to take note, if it says make s the subject of the equation, s can only be in one spot. If you've got s on the left and the right, it's not good enough. And of course, like I said with the other problem, if you've got a square in it, then it's not there yet. It has to be that variable all by itself on one of the sides. You might be tempted to square root both sides, for example, and get s equals the square root of that right-hand side, but there's s's there, so we can't do anything about it. Almost always, the safe bet is to multiply both sides by a denominator if there's one there, almost always. So we get that, which leaves us with s squared outside of 1 plus s is equal to a plus s cubed. Okay, now we're going to do expansions formally a little bit later on. This is not that complex. This is like year 8 with a smattering of year 9 expansions. And we know that the thing outside the bracket gets multiplied through to everything inside the bracket. And so we have s squared plus s cubed is equal to a plus s cubed, like so. So s squared times 1 is s squared. And then if I multiply s squared by s, I just raise the index by 1. Now, I would need to get rid of the s cubed from the right-hand side. I want to collect my s's onto one side of the equation. So I subtract s cubed from that side, and I do it from that side. And thankfully, that actually gets rid of the s cubed, leaving me with just a on the right-hand side. And so s is equal to the square root of a, and we're done. So if you got s equals root a, or square root of a, very well done. Okay, any questions on that? So very briefly, I just gave you out your course information booklet. It's worth having a bit of a flick through at some point. Ideally, read through it in your own time, And then if you've got any questions, don't hesitate to come back and ask me things that you're not too sure about. For the year 11s, if you just look at the bottom of page 2, just be mindful of the fact that the way it works, I've just said year 11s because year 12s already know this kind of stuff, is that the way it works is that there are some criteria that are assessed twice, once internally and once externally. So although there are 8 discrete criteria, which are in the middle of that page, if you look down the bottom, to get a particular award, we're looking at it across 13 criteria, because criteria 4, 5, 6, 7, 8 are assessed internally and externally. So you've got, that's a little table down below is what you have to keep an eye on during the year to make sure that you're keeping your ratings quite solid, I suppose, in that area. There will be opportunities for tests and retests, and we will have I think 3 investigations this year. A slight change from previous practice, not that year 11s would know any different potentially, but you'd know from past tests at high school at least. We tend to assess tests on a content criterion, e.g. criterion 4, algebra, as well as a communication criterion. We're going to change that this year because we believe we've been over-assessing communication. So your tests will be marked on the content criteria. Your investigations will be assessed on communication, as well as organisation, as well as whether you can actually do the work as well. Okay. Now, the good news is that means that you're not going to get hammered. I mean, you are still going to assess communication in tests in terms of giving you feedback. Oh, you need to put a bit more work here. This wasn't very clear, that kind of stuff. You'll still get the feedback, but it's just that means that you won't get a rating for that. You'll just get the informal feedback, which I think is good. Forces you to read it, I suppose, well, instead of just saying, oh, I've got a B for communication. But it also puts a lot more emphasis on the fact that you need to get your communication and organisation right in those analysis tasks. If it's not spot on, that's a whole opportunity lost there. So it's a bit of a swings and roundabouts bit, but it's important that each criterion is assessed about the same number of times, which is why we're pulling it back from the tests. I won't do any more on this booklet. I might dip into it at another time, but does anyone have any questions about that? So if you're struggling to get to sleep tonight, you can get this out and you'll be asleep by page 2. So see if you can stay awake at least to read a couple of pages of that, and let me know if there are any issues. The other thing you'll note about maths methods is that we've got 4 lessons a week, 1 1.5 period lesson and 3 1-hour lessons. We tend to cover new material each lesson. We've got a chock-a-block course, and we need to just keep it pushing along. Otherwise, obviously, we don't want to get to the exams and not having covered all the content. So it really is beholden on you. If a concept is not solid for you by the end of a particular lesson, it is really important that you do more work outside of class time, and that you chase me down if there are things that you just need further clarity. And if we can find a free or a lunchtime where we can both sit down and just go through some stuff, it's much better than sort of just letting it slide. Don't let things slide, please. It's really one of the worst things you can do. Be on top of it, be consistent. The number of hours devoted towards study that I've heard is 1 to 1. So for every hour of class time, put in an hour of study. Doesn't necessarily mean homework, because you've got free study periods and all that kind of stuff. But yeah, that kind of thing will keep you on top of your game. Okay, so just because this is our first time using it, I won't over talk it usually. This is basically how it will work when I'm delivering notes to you in class. It'll normally start off with some theory notes, so that's when you can get your summary book out and start writing stuff down. You don't have to write the success criteria down, but the theory notes would be good to write down. But I'm not checking over your shoulder. If you choose to sit there and go, then that's up to you. But I do know that doing gets it into your head better than just watching. But I'll present it on the projector like so. I've split the screen into 4. That way you've got 4 lots of information in front of you. And then we go from, and then I just go through them. So after I've got through these 4 screens, if you like, then I switch over to the next one like so. Okay, so just FYI, that's how it works. If you do fall a bit behind, don't worry, because don't forget this will be a PDF attached to Google Classroom post soon after the lesson. But anyway, here's the success criteria. We'll see how much we can get through today, but I've been rabbiting on a lot, so we've only got 40 minutes left. We're going to look at expansions to start with. This is all revision stuff, making sure that the foundations of your foundations are right. We're going to look at expansions of 2 or more expressions. If you can do that by the end of this session, then that's a tick. Recognize and expand a perfect square. 2 separate words there. Recognize, did you notice it was a perfect square? And then can you then expand it? And by that I mean use the rule for expanding rather than just doing it longhand all the time. Now, if you've forgotten what a perfect square is, I'll be reminding you, but I'm not going back to first principles on how a perfect square rule is made, okay? Because you should be coming into the course with that already known. And if you don't, it's not the end of the world. It just means you might need to have watch a YouTube video or something to brush your skills up. All you have to do is ask. Easy for me to find a YouTube video for you. And the other one, dots, is recognize and expand a difference of 2 squares. Okay, same sort of thing. So I want you to be able to recognize them and then solve problems that use them. So we're going to look at the first one, which is a binomial expansion. So we've got a plus b times c plus d over there. This is just a very generic one. And look, there's a bunch of methods that can be used to solve that. I might just zoom up on that for the time being because it's easier if it is zoomed up. But one of the methods I kind of like is the chicken beak method. And the chicken beak method sort of says I multiply A by C and A by D, then I multiply B by C and B by D. And it kind of looks like a chicken beak. That's why it's called the chicken beak method. But it basically means that everything that's in this first set of brackets is multiplied by everything in the second set of brackets, keeping in mind that those operations there might change whether it's positive or negative. Okay, so chicken beaking. So one at a time, we've got A times C is AC, A times D is AD, B times C is BC, B times D is BD. Okay, all good, single line. Those lines, I quite like using them because it reminds me what I've done and what I haven't done. So if I draw the lines in as I'm expanding, I'll go, oh, shivers, I haven't done B times D. Or, I mean, that's a pretty simple one, I know, but I'm just saying it applies to more complicated problems as well. The method that we use in high school, and it's a good method to use, and it's going to be more useful when we look at some more complex stuff later on, is that we put the parts of the first expression along the side like this. This is called the box method. And we put the parts of the second expression along here, and then we fill in the boxes. So A times C is AC, C times B is CB, or BC, A times D is AD, and B times D is BD. And then we just put them all together, AC plus AD plus BC plus BD. Okay? And the standard sort of way of writing things is kind of in alphabetical order, or if you've got lots of powers, do them in descending powers kind of thing. So that's basically the chicken beak method. And I just thought I'll just do a couple of examples so you can sort of see them, and then I'll let you do some practice on that, and then we'll move on to the next thing. I'm not too sure. I'm happy to go a little bit slower or a little bit faster depending on where this class is at, which I don't know yet. Okay, so I'm just going to freeze that and just go to example 1. So we're looking at x squared plus 1 times x minus 1. And I'll just use the chicken beak method. But if you want to if you prefer to use the box method, that's fine. If you think you can get away with not using anything, that's kind of fine as well. If you just know to multiply everything by everything, that's fine. But I'll just follow through here. So x squared times x is x cubed. Hopefully you're okay with that kind of power multiplication. Same base, So we add the powers together. X squared times x to the power of 1 is x to the power of 3. X squared times minus 1 is minus x squared. And then we do the bottom part of the chicken beak. 1 times x is plus x. And 1 times minus 1 is minus 1. Like so. And just because of the way I've done it, it is in descending powers there. So I've got x cubed, then x squared, then x. So that's a decent way of writing it. By the way, that expression, by the way, is called a polynomial. Okay, it's an expression with variables in it, and the variables have been raised to powers. And we can talk about the degree of the polynomial. And the degree of the polynomial is simply the highest power of, in this case, x. So the degree of this polynomial is 3, right? Highest power of x, that's all. Doesn't matter whether the x cube was written at the end or not. It's the highest power of x. That has degree 3. Okay, example 2. Same sort of idea. X times x squared is x cubed, because x means x to the power of 1, so we add the indices together. X times x, oh dear, that's not good. Try that again. X times x is x squared, and x times 1 is x. Now, this is a slightly longer expansion because I've got 3 powers, and my chicken beak has this really swish-looking stripe in the middle of it, but it basically works. Okay, now here's another little tip for expansions as well, and that is once you've done the first term in the expression, try writing the next part underneath and keep your like terms together. So 2 times x is 2x squared, so put it here. And then 2 times x is 2x, and then 2 times 1 is 2. And that means you can sort of column add because they're equivalent, because they're like terms. So I can just go down the column. I can go x cubed is x cubed, x squared plus 2x squared is 3x squared, x plus 2x is 3x, and then I've got a plus 2 at the bottom, and there's my expansion done. So I think it's really handy if you sort of do a kind of a column add to slightly longer expansions. That's all I wanted to show you in terms of expansions. It's now 10 past 3. I've got down the bottom right-hand corner there something you can try for yourself. Page 86, exercise 3A, which starts on page 85, and it's questions 5 and 6. Let's just put it into practice and see how you go. And if you're feeling pretty comfortable by the end of 10 minutes, then we'll move on to looking at perfect squares. So where we want to be is at a place where we can recognize certain expansions so that we can apply rules to them, because that's part of our toolbox. And if we can see it, then we can do shortcuts in our mathematics so that we're not always going back to the chicken beak or box method, even though it's a fairly complicated problem, I suppose. So what we have here is the first example of that, and that is the perfect square rule. So the perfect square rule, at the top here, I have the expression in its most general form, a plus b all squared. Or if you look at the right-hand side there, it could be, I'll just zoom up a bit, it could be written as a plus b times a plus b. Both of those are in perfect square form, and that means it's an expression multiplied by itself, which is basically what a square is, right? Now, again, I'm not going to go through first principles of chicken beaking or using the box method. I'm going to go to the result of the rule. And the result of the rule is as follows: that the first term is squared, that the last term is squared, and we've got twice the product in the middle. Square the first term, square the last term, twice the product in the middle. And it always follows this pattern. A good mathematician will develop skills where they can recognize the pattern of what we're looking for. A may be an x. It might be root x. It might be the square root of 17.3. It might be pi, but it is just a number, just like A is just a number. If you see A plus B times A plus B, I don't want to see anyone chicken beaking it or box methoding it. If you see that pattern, that it's something plus something multiplied by exactly the same thing, then I expect you to be able to go A squared plus 2AB plus B squared. Now, if it's A minus B, like I've got on the bottom there, then it's a matter of squaring the first plus squaring the last. And in the middle, same thing, 2AB, but we've got a minus instead of a plus there. So it's only the middle term that is different. Similarly, with A minus B times A minus B, it's A squared minus 2AB plus B squared, like so. That's the pattern. You just need to apply the pattern to different problems that come your way. Here's example 1. Oh, Finn, you thought I was going to pack up then, didn't I? Okay, here's example 1. X minus 3 squared. The first term is, or just X, just where I'm at, but you're on the next step. It's just X. The second term, the B term, is, starts with 3, ends in E, 3, thank you, good, is 3. So the first term squared is X squared. The second term squared is 3 squared. We'll do that in our heads, I hope. The middle term is 2 times X times 3. So that's 6X. And because it's a subtraction, it's minus in the middle. Okay? Now, the problem with, sometimes the problem with students is that because they're so used to doing the chicken beak or the box method, they never take time to practice just the straight application of this rule. And the problem with that is that as it gets more complicated, you're still doing really basic steps there. I get why you do it. It's because you know it so well, it seems easier. But trust me, applying the rule is easier, and if you apply enough practice to it, you'll see that as well. Example 2 is one of those ones with the horrible square root signs, but it's exactly the same pattern. The first term is not X, but X squared. Thank you. The second term is root 3. Thank you for the audience participation. You've been wonderful. Okay, so first term, second term, and it's exactly the same thing in the other set of brackets, right? There's nothing, it's not X root 3 or Y root 3 or 2 root 3. If there's anything different about it, they're not the same. But here they're the same, and here they are the same again. It has to be that exact, okay? Good mathematicians recognize patterns in a precise way. So I'm going to do it in a couple of steps. So we've got the first term squared. Whoops. We've got the second term squared. And we've got twice the product in the middle. And it's a plus. Okay? Twice the product in the middle. 2 times first term times second term. Now, X squared squared is, anyone? X to the power of 4, good. Root 3 all squared is? Yeah, 3. And then I'll do this last bit because it's just messy. 2x squared, 2x squared root 3 is probably how I'd write it. 2x squared root 3. The book would probably say 2 root 3x squared or something like that. I get why they would do that. Okay, so there's just a couple of examples. So what I'll do next lesson, yeah, we've got 5 minutes left. How about you make a start on exercise 3A question 7, but as soon as you come in next lesson, you can just continue on with exercise 3A question 7, and then I'll move on to the third form, which is a difference of 2 squares. So I'll give you a yell out when it gets to 3:45, but just keep working up until end of class time.